Class 12, Exercise 3.1, Chapter is Matrices. So let's begin with the first question. So here we have a matrix. We have a matrix A, and it has three rows, and 4 columns. You can count that right away. And the first part of the problem is write the order of the matrix. Write the order of the matrix. So you have 3 rows and you just write across 3 cross 4 is the order of the matrix, because there are 3 rows and there are 4 columns. Second part of the problem asks the number of elements. So the number of elements, you just are counting how many number of entries are there in this matrix. And so that's basically the product of 3 and 4, and there are 12 elements. 12 elements. The third part of the problem is write the elements A13, so let us write that. A13. So A13 means first row and third column. First row is this is the first row. And the third column is this. So the intersection is the number 19. So A13 is equal to 19. Let's move forward. I won't do A21, A33, A24. Let's just directly do A23. So A23 is the second row, and the third column, and that number is 5 by 2. So A23 is equal to 5 by 2. Similarly, you can do the ones in between. Let's move on to problem number 3. So problem number 2 and problem number 3 are similar. So let's just do one and then move forward. So it asks, if a matrix has 18 elements, what are the possible orders it can have? And what if it has 5 elements? So 18 elements. So basically you have a matrix, and there are some certain rows and certain number of columns. Let's say there are I rows and j columns, So then I times j, the product of I and j, must be equal to 18. So you are basically writing 18 as a product of 2 numbers, and that would be the order. So you can write 18 as 1 into 18. You can write 18 as 2 into 9. You can write it as 3 into 6. You can write it as 6 into 3, 9 into 2, and 18 into 1. And all of these are the possible orders of matrix that you can have. Second, it asks, what if it has 5 elements? So if it has 5 elements, you have to write I times j is equal to 5, and you have to find I and j. So 5 can only be written as either 1 times 5 or 5 times 1. You cannot find any other numbers other than 1 and 5 whose product is 5, because 5 is a prime number. No other numbers other than 1 and itself divided. So these are the orders that the matrix will have. Let's move on to problem number 5. Now problem number 4 and problem number 5 ask you to construct a matrix. I'll skip over problem number 4. Let's do problem number 5, and it follows the same trend. So we have to construct a 3 by 4 matrix, Let's start with the first part, in which Aij equals half times absolute value of minus 3i plus j, So if you write the matrix, it's a 3 by 4 matrix, so 3 rows and 4 columns. In this matrix out here, the first entry, A11, would be equal to half times minus 3 times 1 plus 1. And minus 3 times 1 is minus 3, plus 1 is equal to minus 2. Mod of minus 2 is 2, so 2 over 2 is 1. So A11 is 1. Similarly, you can do A12. So that will be half times minus 3, 1, plus Instead of j, now you put 2. And then you get minus 3 plus 2. Minus 3 plus 2 is minus 1. So half times minus 1, that's just half. The mod of minus 1 is just 1, and that divided by 2 is just half. So you can start writing all these numbers down, and you can continue doing that for all of them, and it would be a nice exercise for you to practice. You can do the similar thing with the second part. If you do the similar thing with the second part, it's still a 3 by 4 matrix, but the rule has changed now. The rule now is aij will be equal to 2i plus j. So 2i minus j, sorry. And so a11 would be equal to 2 times 1 minus 1. I is 1 and j is 1, and that's equal to 1. A12 would be equal to 2 times 1 minus 2, and that's 0. A13 would be equal to 2 times 1 minus 3, and that's equal to negative 1. A14 is equal to 2 times 1 minus 4. That's equal to negative 2. And so you can write all of them down up here. And you can similarly do it for the second row, and you can do it for the third row, and you will get the answer. Let's move forward. Let's do problem number 6. So in problem number 6, you're asked to find the values of x, y, and z from the following equations. So the thing with matrix equality is that all the elements have to be equal to their corresponding elements. So in the first part, 4 should be equal to y, 3 should be equal to z, and x should be equal to 1. So you get the values for x, y, and z. In the second part, you have x plus y equal to 6. You have another equation, 5 plus z is equal to 5. And you have one more equation, x, y equals 8. You're just taking each term and you're equating it to the corresponding term in the second matrix. And if you do that, so basically from the second equation you get z is equal to 0. 5 plus z is equal to 5, and you cancel 5 on both the sides, so you have z equals 0. So you get the value of z. Now you have to find x and y such that their sum, x plus y, is 6 and x times y is 8. And you can try some random numbers, or you can do a quadratic equation for that matter, and you'll arrive at x equals 2, y equals 4, or x equals 4 and y equals 2. This would form into a quadratic equation, by the way, and that quadratic equation would be x squared minus 6x plus 8 equals 0, and you would get the following answer. Let's move on to the third part of the problem. So the third part has two column matrices, and they are equated together. So you get 3 equations right away. X plus y plus z is equal to 9. X plus z is equal to 5, and y plus z is equal to 7. So what you can do, x plus z is equal to 5, and you can put it into the first equation. So the first equation can be written as x plus z plus y. I'm basically just taking this y out and writing it on the other side, and that's equal to 9. That's just the first equation. And using the second equation, x plus z is just equal to 5. X plus z is equal to 5. So y plus 5 is equal to 9, and y is equal to 4. So that's one thing. Now you can put y equals 4 in the third equation, and you would get 4 plus z is equal to 7. So z is equal to 3. Now you have y and z. You can put it into the first equation. X plus y is 4, z is 3, and it's equal to 9. So x plus 7 is equal to 9, and subtracting 7 from both sides, you would get x is equal to 2. Let's move forward. Let's do problem number 9. Problem number 7 is just similar to what we have done in problem number 6. Problem number 8 just asks you what would be the order of a square matrix, and that is just the number of rows would be equal to number of columns. The answer would be m equals n, and so we won't take that problem. Let's do problem number 9. In problem number 9, you still have to find values of x and y that make these two matrices equal. So you have a bunch of equations. The first equation, you have 3x plus 7 is equal to 0. Then you have 5 equals y minus 2. Then you again have y plus 1 equals 8. Then you also have 2 minus 3x is equal to 4. 2 minus 3x is equal to 4. Now you can solve all of these equations. You would get x equals minus 7 by 3 from this. You would get y equals 7 from this. You would again get y equals 7 from this equation. And from the fourth equation, you would get x to be equal to negative 2 over 3. Now notice, for the values of y, you have a consistent number 7. But for the values of x, you have two different numbers. So since there is no single number, single x, there is no right solution. So it's not possible to find any single pair of x and y that will make these two matrices equal. So the correct answer is B, not possible to find. Let's move on to the last problem in this exercise, and it's a really interesting one. So you have to find the number of all possible matrices of order 3 by 3 with entry 0 or 1. So it asks that there are 3 rows and 3 columns. So there are 9 entries in total. And in those 9 entries, you can either have zeros or ones. Either have 0 or 1 in either of them. So instead of directly doing the 3 by 3 part, let's take a smaller matrix. So if you have a 1 by 1 matrix, so just one element, either you can put 0 here or you can put 1 here. So for a 1 by 1 matrix, you have 2 possible matrices. If you have a 1 by 2 matrix, so that is a row vector, that is a row matrix, in which there is one row and 2 columns, so something like this. And here you can put 0, 0, that's one possible matrix, or you can put 0, 1, that's also one possible matrix, or you can put 1, 0, or you can put 1, 1. And all of these are possible matrices, and we have exhausted all the possibilities, and there would be 4 such matrices. So basically the trend here is that if you have n elements in your matrix, then for all of those elements, you would either fill 0 or 1. So for each element, you have 2 choices. For each element, we have 2 choices. And if you have to combine that story for all the n elements, you are essentially multiplying all the n 2's together. So you are essentially getting 2 to the power n. You can observe that right here. 1 times 1 has 1 element, and 2 to the power 1 is just equal to 2. 1 cross 2 matrix has 2 elements, and that has 2 to the power 2, or 4 elements in that. 4 possible matrices. So for a 3 by 3 case, for a 3 by 3 matrix, you have 9 elements. And since there are 2 choices for all the elements, there are a total of 2 to the power 9 permutations, or 2 to the power 9 matrices available for satisfying this hypothesis. And 2 to the power 9 is just 512, and so the correct answer is D, 512. So this video has let you solve the exercise 3.1 from NCERT, and I'll see you in the next video.